palette is kind of like that last option in the Texel, where we use the exact palette that we have currently in the document to quantize the image. Now, we can also selectively pick out colors that we don't want to have in the palette. For example, let's drop the reds. We can choose to take out whatever colors we wish, and it'll re-quantify the solution. That little eyedropper thing, we're going to get that ability as well. What's going to happen is, not in here, but before we create the image, we'll be able to add colors to the palette by picking either averaged or exact colors from the document. So that's a tool that's coming along here shortly. So essentially, we have real-time feedback for everything that's going on. We can manipulate and see the results, and we can produce an image however we choose. Let's open up another example. The other thing Texel gives us the ability to do, or other thing that we have the ability to do, is, oh, that's psychedelic. The other thing that we have the ability to do is when we create a palette, let me pull this out, and let's say that we want to get let's get our orange and our red. So notice what I'm doing. I'm using histogram, which analyzes the image to produce additional colors, and I'm adding to it colors from my existing palette. The next parameter here is a dither, and what that allows us to do is to control the amount that the colors stipple to blend into each other to create a visual representation of color. I think Texel has this ability as well. You have the option here, you can convert it to a design, specify the number of colors, or you can dither it to the design and specify the number of colors. You don't have the ability to dither the histogram, and you do have the ability to dither to the palette. But either way, it's just a one-shot, and it doesn't give you, see, I would almost argue that that's too much. It doesn't give you the ability to control the level of dither. So here we can go all the way from 1 to 8 amounts of dither. So this is controls how much we stipple the image. And then we've converted, those colors have been added to the palette, and you see the image is produced from that dithered image. So we have a lot of control over how we're producing a palette from the image. Get one more example, Blue Hills. The three options here, I'll talk about the technicality that's happening just briefly. The exact palette uses the palette that we have loaded into the document and compares every pixel in the image to find the nearest color in the palette that matches to that palette color. So it'll do the best it can. What the histogram palette does is it takes the entire range of colors in the image and partitions it to a number of buckets that we specify as the number of colors in the palette. And then every pixel in the image, it will fit into one of those buckets, and then all of the colors that fall into that bucket get averaged together. So it produces some pretty good results just by averaging. And if I keep cranking these numbers up, you'll see how it pulls that image out. I personally think that this needs a little dither to make it nice, but nonetheless. So the histogram takes the entire color range and divides it up into the number of colors required. The quantized palette is a little bit more complex. What it does is called octatree quantization, where it takes the entire color space and partitions it dynamically based on how it can fit colors into a palette representation. And the results that it produces is a bit different. It can get better results with fewer colors, and the quantized palette works better for photographic images. The histogram palette works better for line drawing type images, or if you have graphics, for example, a screen print or something. So the quantized palette needs a little improvement. I think the way that it's picking the colors is a little bit rough. It's going to get better, hopefully, before I even make this build. So there's a lot to be done there. Okay, let me close all this down, and let's talk about what the other aspect of all this is. Now, whenever we since we're working with layers, these layers can have transparency, essentially. I'm going to import layers from a file. I'm going to pick, what am I going to pick? You know what? I'm just going to pull it up from my recent list. Okay, this guy has transparency information in it. Not only is the background of the image transparent, but you see as this black fades out into the checkerboard, what's happening is this image has potentially alpha channel data. Whenever we use images with this type of transparency, we have to accommodate for that transparency when we color reduce it to produce a palette. So what I'm going to do is I'm going to select all this information, copy it to the clipboard, and here in my carpet design, I'm going to paste it to a new layer. I don't want to resize the image. I just want to bring it in and make it huge. Okay, so you see the transparency information there. As I zoom in on this, you see how the information fades off. What I'm going to do is, you see here, this is a carpet layer. I mean, an image layer, and that's a carpet layer. So we know where we are. When we take a carpet layer like this that has transparent information and we convert it to a carpet layer, we have to define what happens to that transparency. Right off the top, let me make this a histogram palette so I can analyze and get my blacks and whites. Right off the top, it drops the transparency. It says we can't have transparency in a carpet because, you know, we can't fade out those pixels. So we have a threshold here that allows us to control the actual amount of transparency that will produce these pixels versus the ones that will not. All of these sliders right now are going to get little numeric fields just like this one. Basically, all the way to the right, if the pixel has any transparency, basically alpha below 255, it's going to make it opaque. And as this slider goes all the way up here to the right side, then as the alpha transparency gets higher, I can actually pull out that transparency. So we can control how much of the transparency we're taking using this slider. And better still, my favorite, we can also dither the transparency. So now, as I increase this dither, what's happening is we're creating the illusion of transparency by stippling the pixels of the layers that we're quantizing to produce essentially an illusion of transparency. So if I move cursor, you see as I move that image now, you see those stippled pixels move? Because what's happened is it's diffused the transparency into the true color image, and it creates a convincing illusion of transparency using true color data. Any questions about that?
Nope.
You guys are awfully quiet.
Pretty cool.
So, to kind of summarize, what's happened is we have a new layer type, and that layer type is specifically for storing true color image data. Whenever you open a document that contains true color image data or paste that data from the clipboard, it has to go into an image layer, whereas all the carpet information that we create for the design is stored in a carpet layer. These two layers are distinctly separate. You cannot draw in image layers like you can in carpet layers, but you can make selections, and you can manipulate those selections. You can convert the layers back and forth from one to another so that you can convert an image layer to a carpet layer, you can convert a carpet layer to an image layer, and if you reduce the number of colors, you have a number of ways to do it. Also, if you want to drop all of the layers in your image, you can either flatten the document to a carpet layer, in which case all of the